In this problem, we need to transform the Cartesian coordinate square root of 3 comma negative 1 into its corresponding polar coordinate. Now let us begin. So here we have our Cartesian plane. Here in the fourth quadrant, we have the point P. So we know that this particular point is going to lie in the fourth quadrant because we have the x coordinate, that's a positive value, and the y coordinate is negative 1. So it's going to lie on the negative y-axis. Our goal will be to convert this particular point to its polar coordinate. For that, first we will be joining the point O and P. So joining point O and P, that's going to give us the radius R. So this is going to be determined by taking the square root, and underneath the square root, first we'll take the x coordinate of point P, square it, and then add it to the square of the y coordinate. So we have square root of 3 whole squared, that comes out to be 3, added to negative 1 squared will be 1. We get square root of 4, which is 2. So we found out that the distance of origin to the point P given by R is going to be 2 units. The next task will be to find out the angle. To find out the angle, we'll drop a perpendicular from the point P on the x-axis and going to name it OA. So here OA is going to be perpendicular on the x-axis, which gives us the right angle triangle OAP, right angled at A. Let us consider the triangle. In the right angle triangle OAP, we will try to obtain this particular angle phi. We'll try to compute this value. Tangent of this angle phi, that's going to be given by the y coordinate, or you can say AP, divided by the side AOA. Now AP, it has a length of negative 1, but we are only going to consider the magnitude, divided by OA. So OA is going to be square root of 3. So this gives us a value 1 over square root of 3. Now we know that tangent of pi over 6, or that means tangent of 30 degree, has a value equivalent to 1 over pi square root of 3. So this gives us the value of phi. So our angle phi is going to be 6. But actually we do not need angle phi, we need the angle theta. Now the angle theta is measured in the clockwise fashion, coming from the positive direction of x-axis. So theta is going to be defined as the angle phi, but going in the negative direction or in the clockwise fashion. So theta comes out to be negative pi over 6. So this is going to be the angle theta. And there is another way. If we can also measure the angle coming in the positive direction or in the anti-clockwise fashion, in that case, then angle theta is going to be equals to, in that case, theta will be equals to, so we will take the full revolution 2 pi, and from it we are going to subtract the angle phi. So we have theta equals to 2 pi minus phi over 6. So that's going to be 11 pi over 6. So this is another possibility. So finally we get two values of the point Po in its polar form. One of the form will be P. We have 2, that's the radius, and the angle is going to be negative pi over 6. Or if we want a positive angle, then this can be also expressed as 2 comma 11 pi over 6 radians.